In this video, I am covering top 10 scenario-based Spring Boot microservices interview questions, and these are not simple definition questions, and these are the scenario-style questions that senior developer and the lead developer faces in the actual technical round. So let's get started. Now, question 2 is your microservice team debates like should each services have its own database or should all the services share a one PostgreSQL instance to avoid the data duplications. So this is a classic architecture's debate questions. So most candidates say a database per services, but the interviewer wants to see if you understand why and can define the trade-off. So database per service is correct. Each service owns its data exclusively. This is called the shared nothing principle in the microservices. Shared DB creates like hidden coupling. A schemas change in the shared database affect every services at once. So you lose independent deployability completely. No direct cross-service database call. So service A must never query service B database directly. All the data access goes through B's API on event. And sync via event or API call. Use Kafka event or REST call to keep the data consistent across services. This is called eventual consistency. Handle reporting with real models. So for join across services, build a dedicated read model or send data to the data warehouse, not a shared OLTP database. Accept the trade-off honestly. So more infrastructure cost and eventual consistency can a real downside, but independent scaling and the deployability justify them. Exception: shared reference data. Read-only reference table like countries or the currencies can be shared or the replicated, and they rarely changes and don't couple services. So first scenario question is your order services calls payment services and the payment services start timing out under load and orders pile up. User sees errors, and how do you fix this without taking down the order services? So this is one of the most commonly production problem in the microservices. The interviewers is checking whether you know how to isolate a failing dependency before it cascade. So let me go through like first point, like identify the root cause. So payment service is slow, causing order service thread to block and pile up. This is called the cascading failures. So second point is introduce circuit breakers. Wrap the payment service call with resilience 4j at the rate circuit breaker. This act as a safety switch between the two services. Closed state normal operation. In closed state, all calls passes through normally and the breaks track the failure rate in a sliding window of 10 calls. So open state, it's a short circuit. When the failure crosses 50%, the breaker trip to open and all the call immediately return the fallback. So no network call made at all. Then is half open, like it is probe recovery. After a configure wait, the breaker allows a few test call through. If they succeed, it is start to closed. If not, then stay open. Implement a fallback method. The fallback can return a cascade price, queue the order for retry, or return a partial response. Something useful, not just an error. And add time limiter for first fail. And at the rate time limiter within 2 second timeout ensures the order services never wait more than 2 seconds. So it's fail first rather than the blocking the. Now let's understand about the scenario. User logs in at API gateway. The request flow through 5 microservices. How does each services know who the user is without calling the auth services or on the every single hop? So this is about the stateless authentication in distributed system. So interviewer wants to see that you understand JWT as a self content identity tokens, not just an like a login mechanism. So JWT carries identity and it's stateless. A JWT is an self-contained signed token with an user ID, roles, expiry. No database lookup needed to validate it. Gateway validates once. The API gateway validates the JWT signatures with the public key. This is the only services that touch the auth server per request. Token pass downstream. So after validations, the gateway forward the original authorization header to every downstream service without modifications. Each services reads claim locally. Order service, payment services, each extract user ID and the roles and the token claims in the memory. So no network call in auth services. FIN interceptor auto forward. So a FIN request interceptor automatically copies the authorization header on every outgoing service to service call. No manual code. So truly stateless and the scale freely because no session state is stored on the server. So you can run 100 instances of any services and any instance can handle any request. Token refresh at author's refresh API. So when the access token expires, the client uses the refresh tokens to get the new access tokens. So refresh endpoint is the only auth service call. Before understanding the scenarios 4 and remaining other 7 scenarios, so if you are still watching the video, I request to please subscribe to the channel and like the video, and if you have any doubts you can mention those on the comment section. And user reports their order is stuck and you have 8 microservices. Logs are scattered across the different services and the machines. How do you trace this single request across all the services in the production? So this tests the production operation knowledge. Knowing how to debug a distributed system is what separates a senior developer from mid-level. Use distributed tracing. So micrometer tracing with the Zipkin or the Grafana tempo gives you a unified view of every services a single request touch. Every request gets a trace ID. When the first request enter the gateway, a unique 64-bit trace ID is generated and attached to the request for its entire life cycle. Trace ID propagates via headers. The trace ID travels in the HTTP headers, especially XB3 trace ID, and every services automatically forward it on outgoing calls. Services creates the child span. A span represents one hop. The order services creates a span. Payment services are then a child span. Each records start time, end time, and the status. The Zipkin UI shows full call tree. To search by the trace ID in the Zipkin UI, so you can see the entire journey which service was called, in what order, how long each hop took. So inject trace ID into an every log line. So use map dynamic concept. So you inject the trace ID into your log statement, so you can grab the log across the service by the same ID. Add timed annotation for the custom matrices. Annotated critical method with time to trace their latency and correlate in Prometheus. So this surface bottleneck before the user notice them. Next scenario is placing an order involves like a deduction stock in the inventory, create an order in an order service, debit the payment in the payment service. So across the 3 separate services, if payments fail after the stock is already deducted, then how do you ensure the data consistency? So this is one of the hardest distributed system problem. The interviewer wants to hear SAGA compensating the transaction outbox patterns, not just like two-phase commit. Two-phase commit block all the participants and is too slow for distributed microservices, so avoid it entirely. SAGA is the correct patterns. A SAGA is a sequential of the local transaction. Each services does its own DB write and publish an events to trigger the next step. Orchestration SAGA approach and orchestration. An order orchestration service drives the flow. It sends the command to inventory, orders, payments in the sequence, and trace the overall state. Step by step flow. Step 1, reserve stock. Step 2, create the order record. Step 3, debit the payment. Each step only proceeds if the previous one is succeed. Then compensating the transactions on fail. If the step 3 payments fail, the orchestrator trigger the compensation, cancel the order in the service 2, restore the stock in the step 1 in the reverse order. Outbox pattern for the reliability. When the service publishes an event, it writes to an outbox table in the same local DB transaction. So events and the data exchange are atomic. Divisium read outbox to Kafka. So Divisium watcher the outbox table via change table captured and publish the event to Kafka. So guaranteeing at least one delivery without a distributed transaction. Scenario 6 is like your mobile app is hitting the production API 1000 times per second during a flash sale. So the service crash under the load. You need to protect it without blocking the legitimate user. So this is about API protection at scale. The interviewer wants to see you think in layer, gateway level protection, the algorithm choice, and what happens to the rejected request. So rate limit at the gateway layer. So Spring Cloud Gateway is the right place for the rate limiting. So it's protect all the backend services without any code changes in individual services. Use the token bucket algorithm. The token bucket algorithm gives each user a bucket of token. So each request consumes one token and tokens reload at a steady rate. Redis for distributed state. When the multiple gateway instance rate limit state must be stored on the Redis. So each instance shared the same token bucket per user. Set limit per API key or the user. So 100 requests per second API key is typically limit. So set the lower global limit for unauthorized user to prevent the abuse. Return HTTP 429 with an retry after. When the request is rejected, return 429 too many requests with a retry after header telling the client exactly what to try again. VIP tier with a higher limit. So premium or the partner API consumer get a separate rate limit configuration, like same infrastructure and the same bucket size they can use. Add bulkhead to limit the concurrency. Resilience 4J bulkhead limit the number of concurrent thread processing requests. So rate limiting control volumes, bulkhead, and the consistency. You have 20 microservices across dev, staging, and the production environment. Changing a single features flag requires rebuilding, redeployment, all the 20 services. So how do you manage the configuration centrally and update it without restarting anything? So this is about operational maturity. Any company with more than 5 microservices need a centralized config. The interviewer wants to see how the full Spring Cloud config ecosystem. Do you know about this Spring Cloud config ecosystem or not? So Spring Cloud config server, a dedicated config server read the properties from a Git repository and serves them to all the microservices on startup and on demand. So service import from config server. So each services has the spring.config.import equal to config server. In its bootstrap config, it fetches its property automatically. Environment specific file in the Git like app dev OML, apps staging OML, prod OML lives in the Git repo. The active Spring profile determines which flight to load. Refresh scope annotations for live reload. Any beans annotated with refresh scope will be destroyed and recreated with a new value when the refresh is triggered. No restart is required. Then at actuator refresh trigger, the calling actuator refresh endpoint on a specific service instance forces it to pull the latest config and refresh all the refresh scope bin. So Spring Cloud Bus broadcast refresh. So Spring Cloud Bus, like backed by Kafka or RabbitMQ, broadcast a refresh event to all the services instance at once with a single API call. And then is Vault for secret management. So never store the password or the API key in the Git. Integrate Vault with config server. So secret are fetched securely at runtime. Next, the scenario 8. Your order service is hard coded to call the payment services on the port 8081. In production, payment services is scaled to 5 instances with dynamic assigned IP addresses. The hardcode URL breaks instantly. So what is the solution here? So this is the fundamental microservice question. So hardcode URL are the first things you eliminate when moving to the dynamic environment. The interviewer wants to hear like Eureka, registrations, and the client side load balancing. So hardcode URL breaks like dynamic environment assigned a new IPs every time a container is started. So hardcode URL fails the moment a service restart or scaled. Service registry with Eureka. So Eureka server is a registry. So every service register itself on the startup with its name, host, port, and the health check URL. Register with application name. So setting the spring.application name equal to payment service cause the service to register under the logical name, not its like IP address. Call by name, not by the IP. So order service calls the HTTP payment service slash API slash pay. So Eureka resolve these two on the like live instance automatically. Load balanced REST template. So adding either a load balance in your REST template or using fin client tells the Spring to reserve the service name by Eureka and the load balance. Then round robin load balancing. The Spring Cloud load balancer attributes request across all the healthy instance in round robin order by default. So no external load balancer needed. Heartbeat keeps the registry fresh. So each service sends an heartbeat to Eureka every 30 seconds. And if the Eureka is missing 3 heartbeat, it removes that instance from the registry automatically. Next, move to our scenario 9. When an order is placed, the order service must notify the inventory, notifications, and the analytics services. So direct REST call to all the three makes the order service tightly coupled. And how do you decouple this? So this is about event-driven architecture. The interviewer is checking whether you understand the loosely coupling through asynchronous messaging and whether you know the Kafka specifically or not. So event driven with the Apache Kafka. So order service published a single order placed event to an Kafka topic. It does not need to know like who is listening and how many consumers exist. Producer published to an topic. So Kafka template sends like order event, order ID, order placed event. Once published all, the Kafka handles the delivery to all the consumer. Inventory, notification, analytics each have their own consumer group ID. So this ensures each service receives every message independently. Consumer process independently. So each consumer process at its own pace. So analytics can be slower without affecting the inventory or the notifications. Add consumer with the zero changes. Adding a new consumer like fraud detection services requires the zero changes to the order services. You just create a new consumer group. Then Kafka listener annotations. Kafka listener annotations, topic and the group ID. This is the entire consumer configurations on the receiving end. DLT and retry on field messages. So other retrievable topic configures the automatic retry with the backup messages that keep failing go to a like a dead letter topic for the manual inspection. Then our last scenarios question is your product catalog API is calling 50,000 times per minute. So profile is showing 90% of the calls are at the same 100 products. Your database is overloaded. How do you reduce the load without changing the database model? So this is a performance optimization questions. The interviewer wants to see a multi-level caching strategy, not just like using the Redis or using those. So you understand like local versus distributed caching and the caching invalidation. So multi-level caching strategy, like layer 1 is the local cache for each instance for some millisecond lookup. So layer 2 is for the Redis for share distributed cache across all the instances. Cacheable on the service method. So at the rate annotation cacheable using the product and the key as product ID tell the Spring to check the cache first. If the value is there, then the method body never execute. And first call populate Redis. So on the cache miss, the Spring call the real method and get the data from the database and store it in the Redis with a for example 10 minutes detail automatically. Subsequent calls skip the DB, so every call within those 10 minutes hits the Redis instead of the database. So 50,000 call become essentially like zero database query with those 100 products. Caffeine for the hottest item, like local caffeine cache on each services instance respond in under 1 millisecond, so no network hop is to call. So perfect for for example top 10 most requested product. Then cache await, keep the data fresh, so when a product is updated though, so it's remove the specific entry from the cache, so the next call get the fresh data. Cache aside patterns, the cache aside patterns means the read from the cache and if miss then load from the DB, then and the store in the cache. Your application control this cache populations logic. So these are the exact scenarios that get asked in on the scenarios based in senior on the lead level roles, different product based and the service company. Now you are more prepared than the majority of the candidates. So difference is that you should not think about the code, you should be thinking in the system level as well. So if this video helped you, please hit the like button and subscribe to the channel to get the daily videos on the Java interview questions, Spring Boot, system designs. So all the best for your interview, and thank you.